Welcome to GATE class video. Now I am going to take classes in the operational amplifier. First I am introduce myself. I am J.MEGALA, Associate Professor in EEE Department working in SA Engineering College. Now I will start that class. So first I will take that operational amplifier and its basic application. Now, so operational amplifier, it perform many mathematical operation as well as the different signal wave generator and multivibrators, analog to digital, digital to analog converters, voltage to current, current to voltage converters. So many applications you have to do by using that IC741 operational amplifier. Here we discuss only that few applications. The next video we will continue that remaining applications. Now we will start the first application, inverting amplifier. The inverting amplifier is nothing but the amplifier. We can give your input to the non-inverting input terminal of the operational amplifier like this. So your input is given to the inverting input of an operational amplifier. So you can get that output is minus RF by RI VI. So why you can get it that minus RF by RI means you can go the current equations. In ideal operational amplifier, we can assume that the voltage at this node point is 0. So the input current flowing to that input terminal as well as the feedback current are same. We can assume that first things. So based on this calculation, so the output voltage you can get it from minus RF by R1 into VI. So this is for the inverting amplifier. Now the gain of the inverting amplifier for this configuration V0 divided by VI is equal to minus RF by R1. Some gate questions they will given us the value of R1 RF, then they will calculate that open loop gain. Sometimes they will ask, they will given us V0 and Vin. They will asking the question is what is the ratio of RF by R1. So we can able to answer it. So this is the important equation. Now the next application is non-inverting amplifier. Non-inverting amplifier means it amplifies the input signal. So only thing is you can give your input to the non-inverting terminals of the operational amplifier. Like that pin number is 3. So you can give your input to the non-inverting terminal. Then the inverting terminal, the resistor input side is connected to the ground and then feedback is also available. For this case category, same thing we can consider as this is the ideal operational amplifier. The current flowing to the input as well as the feedbacks are same. Then the voltage at the node point Vn, that means the inverting as well as the non-inverting terminals are 0. You can consider that, then you can do the derivation. We can get the final output is V0 is equal to 1 plus RF by R1 input resistant into VI. So therefore the gain factor for this non-inverting amplifier is 1 plus RF by R1. Okay. So it's here also the same thing. They given us the value of RF and R1. They will ask that open loop gain. What is that open loop gain? Some question paper they will given us the input and output voltage. They will ask the ratio of RF by R1. Now third application is adder. Adder means summer. So summing amplifier, you can give your more number of input voltage, you can sum and produce that output. So the summing amplifier is categorized into two types. One is that inverting mode and another one is a non-inverting mode. Here this example is you can give your multiple of input voltages in the inverting terminal alone, not non-inverting. So non-inverting summer means you can give your input voltage in the non-inverting terminals. Now here I am given in that 3 voltages V1, V2, V3. So according to the ideal cases, ideal operational amplifier, the input current is same as the feedback current. Now the node point voltage at that inverting terminal or non-inverting terminal, we assume that is a 0. So in that case we can measure that what is the total current flowing to this. According to the Kirchhoff current law, we want to write it down. The current entering to this common node point at inverting terminal is I1, I2, I3. This is equal to the leaving current. That means the feedback current RF or IF. Then now you want to substitute. So how can you find out this value? Means V1 minus this node voltage is 0. V1 minus V2 divided by R1. This is that I1. Similarly, you can find out that I2, I3, I4. You want to find out that RF feedback current I4 means this node voltage 0 minus the output. So we can through that current flowing directions only we can write down that voltage. So after simplify it, we can get this answer V0 is equal to minus of, because you can give your input voltage in the inverting terminal, it produces a 180 degree phase shifted as output. So minus Rf by R1 into V1 for input 1 voltage 1 plus Rf by R2 V2. So n number of voltage you can give it to in the inverting terminal. So finally for your choosing that value of R1, R2, R3 which is connected to the input terminal is the same value, means the output voltage is reduced to minus Rf by R into V1 plus sum of the all the voltage input voltages. So sometimes they will ask in the question questions, they will given that V1, V2, V3 value, then they will given us the V0 value, then again they will ask this ratio. So this ratio is the most important, Rf by Rn or Rf by R1 or Rf by R. Now the next important amplifier, operational amplifier application is difference amplifier. Difference amplifier, the difference of the two input signal, it gets amplified. So this is the diagram. So you want to give your input voltages in the two different inputs terminals of the operational amplifier. I am given that V1 through the input resistance R1 in the inverting terminal, V2 given in that through that potential divider R2 R3 in plus non-inverting terminal. So we want to reduce it. So listen carefully. In this difference amplifier, we can assume that don't minus and plus, don't take it as a minus plus. Anyhow the V0 is directly proportional to these two input voltages. So V0 equal to V1 and V2. So first you can listen that V1. So in this V1 is connected to the inverting terminal. So it's behave like an inverting amplifier. So inverting amplifier mode means you produce the output in the inverting mode, means what is the formula for V0 in the inverting amplifier? V0 is equal to minus Rf by R1. So into V1. So this is the case number 1. Second case, you want to write down that added with the non-inverting mode. So added with the non-inverting mode voltage, non-inverting mode. Suppose this circuit operated in the non-inverting mode. So what is that output? You want to find out. So here V2 is given in that R2 terminal, but the one potential divider will be there in the R3. So keep in mind the node, this point, the voltage across this point only given to the non-inverting terminal. So this point you want to write it down. So this point we want to write it down, this voltage V2 dash. This V2 dash is nothing but V2 dash is equal to voltage across this R3. Voltage across the R3 means we will go to that voltage divider rule. That means total voltage into R3 divided by corresponding resistor divided by sum of this resistor R2 plus R3. Okay. Now into you want to multiply this V2 dash. This V2 dash. Actually your original input is given to the non-inverting terminal is V2 only, not V2 dash. So you want to find out that V2 dash. V2 dash is nothing but V2. You got that answer, V2 dash. Now you want to find out that V2. V2 is nothing but V2 dash into 1 plus Rf by R1. 1 plus Rf by R1. Suppose if you have any doubts, you can write it like this. V2 is equal to, here we want to write it like this. V2 dash R3 into that. Now like V2 dash. So you want to write it like this. V2. Here V2. So total voltage. Now you want to write it down. V2 dash is equal to V2 into R3. Now, so you want to calculate that V2 dash is nothing but the voltage gain is 1 plus Rf by R1 in case of the non-inverting amplifier. So in case of the non-inverting amplifier, V2 R3 by R2 plus R3 into, we want to write it down, R3 divided by R2 plus R3. So this is your equation. So this is the equation we want to substitute here. Then this gain formula, this one voltage divider. So among this is a V2 dash, that means non-inverting mode voltages. So that's why here given 1 plus Rf by R1 non-inverting mode gain factor is multiplied with your V2 R3 divided by R2 plus R3. So this is the voltage you want to write it down. Now, so if we want to go for the next slide, voltage follower is the important application of the operational amplifier we can use for the impedance matching purpose. How to make your non-inverting terminals is a voltage follower. Non-inverting terminals. So this is a non-inverting amplifier to make your voltage follower. In this input resistor, we can take it as a open circuited, high impedance, high input impedance. Voltage follower generally it has a high input impedance and low output impedance. So that's why here that input resistance Ri is a open circuited. It produces a high input impedance. Then the feedback is low resistance. Output side is a low resistance. That's why it's connected in the short circuit. So input is given to the non-inverting terminal. So this circuit is behave like a voltage follower. Voltage follower is nothing but the emitter follower. It's like a emitter follower in case of the BJT. In case of the field effect transistor, is nothing but the source follower. The gain should be the maximum. So what is the properties of voltage follower using the op-amp means input impedance of this voltage follower is high, output impedance is low, then the gain factor is 1 because the output is same as input. Now, so next application is we want to go for the integrator. Your operational amplifier, it perform like a integrator. Integrator means you can give your connections. Input side is a resistor and feedback side is a reactance components capacitor. So by using this R and C, we can similarly, in case of idle cases, this node voltage is 0. The current flowing to the R1 resistor is equal to the current flowing to the capacitor. So based on the current equation, we can get it thus V0 is equal to minus 1 by R1C integration of input voltage. Sometimes they will ask what is it, the value is given that R1 and C1, then they will ask the gain factor. So what is the gain factor here means the 1 by R1C is the important gain factor for this circuit. Similarly, we can go for the differentiator. Differentiator means your operational amplifier performing that output directly proportional to the differentiation of input voltage. So here is behave like a high pass filter also. So input side you can connecting the capacitor, the feedback side you can connect the resistor. Now similarly you can assume that idle cases both the current are same. This voltage is 0. In that case after derivation you can get it the final equation minus Rf into C differentiation of input voltage with respect to the time t. Now one small problems. The first problem is given in the gate question paper. Consider this circuit with an idle op-amp. They said idle op-amp means the point voltage at this point is 0. Here also 0. Inverting and non-inverting terminals also 0. So it's shown in the figure. Assume that they will say input voltage far less than the supply voltage VCC. V reference also far less than VCC. In that case, here you can consider is a 0 voltage for idle cases. Here both the V in and equal to V reference. Here they given us plus or minus. Here given us the minus and plus. So both are the same. It connected to the inverting terminal. So what will happen if the input voltage is equivalent to V reference? Both are connected to the ground. So the voltage at this inverting terminal is 0. So what they asking, V reference is far less than VCC as well as the V in far less than VCC. In that condition, at which condition the V out is equal to 0. For this condition only is equal to 0. Now we can go for the next problem. Next problem, they will ask to find the expression for the output. They given us the expression, that's it, 1 plus Rf by R1 into Vp. So they given us that Vp equal to R4 divided by R4 plus R3 into Vi. So you want to, from that equation you want to make your diagram. Now, so this is that output diagram. So this is like a difference amplifier, but keep in mind in this case here there is no any inverting mode. Inverting mode. So inverting mode means here the inverting terminal, this inverting terminal is connected to that grounded. So there is no any voltage is given. Here another voltage is given, that is VI. Your output is in terms of VI only. So here VI will be there, VI. The next thing is your potential divider is R4 divided by R4 plus R3. So you want to find out like this. So R4, R3 we can connect it. Your gain of the non-inverting mode is 1 plus RF by R1. 1 plus RF, RF, R1. So this picture is behave like a non-inverting mode of operation, but in case is difference amplifier. So that's why you can get it answer. Actually this portion plus RF by R1 minus into V. This is a VI means some other VI2 something like, but this is not there. So it's connected to the ground. So that's why we want to put this 0. So this is that output. Sometimes they will given this type of diagram, they will asking that what is that output. Is another gate question. Now the next thing is the inverting operational amplifier shown in the figure. They will given that inverting operational amplifier. So here 1 kilo ohm they given, 10 kilo ohm given. This is a closed loop gain, they also they given us here. The closed loop gain. The closed loop gain is given here V0 by Vs. They will ask what is that closed loop gain V0 by Vs. This is that inverting terminal. When inverting terminal means for the gain factor, inverting terminal the gain factor is equal to minus RF by R1. So this is my gain factor. So what is the gain factor? Here given that RF value is 10 kilo ohm and R1 is that 1 kilo ohm. So you can get the answer is that minus, you can get the answer is a minus 10. So this C is the answer for this type of problems. The next one, so another problems we can go for if the operation amplifier in the figure is idle, they will given. So in that idle cases, I said the input current is same as the output current, feedback current. This node voltage is 0. So here also the 0. So this is nothing but the difference amplifier. So in case of the difference amplifier, this is the final equation. RF by R1 into V1, 1 plus RF by R1 into R3 divided by. So this is that R3 divided by R2 plus. This is the R3, this is the R2, this is the R1, this is that RF. Okay. So you can substitute this equation. You can get the final answer is that B, that is 6 volts. Okay. So minus RF by R1, 5K divided by 1K. That is the 5 into, so 2 volts. So you can go through these cases. We can get the answer is that B only 6 volts. Now, so fifth problem also same. This is a maximum the gate question paper from the difference amplifier configuration only they will ask in the different patterns. So this is also another type of the difference amplifier, but here they will given us the common input. So both the negative and inverting and non-inverting terminal connected to that 1 volt only. So through the 1K resistors only. Okay. So here also the same equation we can follow it. From this equation, minus RF by R1 is equal to 2K divided by 1 into what is the voltage? V1 is a 1 volt. V2 also here 1 volt. You can simplify. You can answer. You can get it that answer is that minus 0.5 volt only. Okay. Now sixth problem. The problem is coming from the as per the diagram. So here given the capacitor and resistor and feedback resistor will be there. Okay. So this is nothing but this is for that they will avoid that noises. They will given that additional R1. Actually the C and the R2 is made your operation amplifier perform in the differentiator only. So the differentiator behave like a high pass filter. Integrator behave like a low pass filter. So C and and R2 will be there. So this is behave like a high pass. So your answer is first choose it high pass filter, but here the two form answer will be available. So one thing is here they will mention as in the frequency range radians per seconds only, but here the frequency is decided only these two component. So integrator and differentiator in any kind of circuits, so the frequency of the integrator or frequency of the differentiator decided by the component available in the input terminals, like a C into R1. Don't choose that R2 feedback resistor. So this is the B is that answer for 1 by R1 C into radians per seconds. Now is another problem. So same thing, ideal operational amplifier circuit is given. So next thing is the 3 dB frequency range also is given, 3 dB decibels, the gain factor is 3 dB. They will ask that the voltage gain is decreased by the 3 dB from maximum value. Now you tell me that which of the option is correct. Now here also the capacitor and resistor will be there. The capacitor and resistance default is the high pass filter only. For in case of the high pass filter, so what is the formula? 1 by R1 into C. So 1 by R1 into C. R1 value is 1 kilo ohm, 1 into 10 power 3. C is the 1 microfarad, 1 into 10 power minus 6. So 1 divided by this product, it gives that thousands only. Okay, so thousands only. For the 3 dB frequency range is a thousands radians per seconds. So this is correct answer. This is as a high pass filter. So that's why you can use that two options B and C for this question number 7. So next thing is question number 8. Operational amplifier is to be idle. Similarly, they will given us that operational amplifier is that idle case. In this idle case, the voltage gain of the amplifier also they will ask from this diagram. In this diagram is nothing. You are given the input voltage to the inverting terminal. The non-inverting terminal is connected to the ground. So this is nothing but inverting amplifier only. So additionally, they will given us the R3 value. So here R1 and R2. So actually R2 is nothing but they connected in the feedback. So this is nothing but the feedback resistor. So actually in the idle case, this is the node voltage is equal to 0 cases. Now the current flowing to the R1 and R2 are same thing. We want to calculate it. Then now therefore default the V0 is equal to minus R2 divided by R1. Okay, R2 divided by R1. When this node voltage is 0, this n equal to 0 case is the assumption. For idle cases, the node voltage is 0, now output also 0. So output also 0 means this is considered as a 0 volt, is considered as a open circuited only. Okay, so that's why this load will be there in this feedback. From this feedback you can calculate the V0 is equal to minus R2 I1. So this is your final answer. Now so next applications point of view, first order low pass filter, the next high pass filters are there. Is another application. Similarly, this application is a inverting amplifier only. In this inverting amplifier, they will ask the question is the derivations or answers. The previous derivations answer. Likewise, you can get it. So next applications are low pass filter, high pass filter, and then multi vibrator, sinusoidal oscillators are there. So many things are there. We will see in the next class video. Thank you.